So we are trying to relate magnetic permeability and magnetic susceptibility. When I was studying this for the first time, I thought if a material allows a magnetic field to go through it, so it has to be magnetically susceptible, right? It made sense. But of course, it's nature. There are exceptions, and they are exceptions. And that's a small thing that I wanted you guys to know. So it's not part of your exam, but I just felt like letting you guys know. This is what I thought when I was studying once upon a time. And now I thought, some of you might be curious. So let's look at the math. We're trying to relate mu and susceptibility. Okay. So that's what we're doing. Let me do it here itself. Mu and this is what we're trying to relate. Now let's consider a linear magnetic material subjected to this external stuff, and it develops M magnetization and with an induction of B. So basically it's something like this. Okay. So what is that we're looking at? So then when there is no current, the solenoid is just a material. When we have some current, it gets magnetized, so we see deflection. When we keep a soft iron, you can see the difference. So here I'm keeping a soft iron. So then when you see that I push in the soft iron, the deflection increased. So we are looking at this particular scenario with the soft iron. So what happens? Not only the external magnetic field influences it, the material itself will have its own stuff happening. So since we have to relate it to the materials permeability per se, materials magnetic permeability. So we need to express B as mu H. Okay. So in presence of the same field, what's happening with it? That's represented by mu H. So here mu S permeability of the material. I guess, does it make sense? Same source. This is this is in the raw form, equivalent to the raw form. This is without the raw form. This is as a whole. The entire setup, this is the expression. So we have mu H that I can equate it to mu naught H plus M. Still, we don't have the susceptibility. Still not yet gone over there. How do we do that? So susceptibility is given by H by M by H. It is M by H, right? Just a second. Yeah. Okay. So I can substitute here. Let's substitute this. On substituting, we end up with what? Mu H, which is equal to mu naught H plus, in place of M, that's it. So in all the term, H is common. And so we have mu is equal to mu naught 1 plus. That's your answer. So material is related to susceptibility, but not quite linearly. I mean, it is linear also, but not exactly. Like, it's just not key 1 and 1 over here. Right? One increase will not lead to one increase over here. There's something else. The factors are different. So we have to look at the relative permeability also. So it's quite simple. This is nothing but mu naught mu r, right? And so this is equal to mu naught 1 plus. So this and this will get cancelled. 1 plus. Okay, guys. Again, this is a different expression. It's per se a different derivation in some sense. So this is your answer. Actually, this is an extra bit of information. They can ask you that also. Okay, yeah, now it's time for you guys to pause and have a look.